Good morning, my dear children. Welcome to the mathematics class. Today we are going to discuss integrals. In this chapter, we are going to discuss the concepts of exercise 7.4. In the previous class, we have discussed the concepts of exercise 7.3, and also we have done the sums in the exercise 7.3. I hope you have learnt the concepts of exercise 7.3 well, and also you have prepared well the sums. You have done well the sums in the exercise 7.3. Okay, my children, I hope you don't have any doubts in that exercise. Okay, my children, now come to this exercise 7.4 concepts. Are you ready to listen the class? Right. Integrals of some particular functions. In this exercise, we are going to find the integrals. We are going to find integrals of some particular kind of functions. Especially the integrand is in the form of a quadratic expression. If you observe, these are all formulae. In this exercise, we mention below some important formulae of integrals, and we apply them for integrating many other related standard integrals. Okay, my children, here I wrote 6 integral formulae. See here, integral dx by x square minus a square. If you observe the denominator, it is a quadratic expression in x, and moreover, coefficient of x square is 1. Remember this point, my children. Every time you have to make the quadratic expression with coefficient of x square is equal to 1. If it is not so, we have to take that coefficient of x square outside. Okay, my children, understood this point. So, integral dx by x square minus a square is equal to 1 by 2a log mod x minus a by x plus a plus c. This is the formula. Okay, my children. Now come to the second. Integral dx by a square minus x square. Here also it is also a quadratic expression in x, but here first is constant term and second is x square term. Okay, my children. Here also coefficient of x square is 1. You keep this point in your mind, my dear children. The quadratic expressions will be given in the denominator. Okay, my children. In all these cases, we have to make the coefficient of x square as 1. If a coefficient of x square is not 1, we have to take it out, the coefficient of x square outside. Okay, my children, we have to take the common factor. Now, 1 by 2a log mod a plus x by a minus x plus c. Okay, my children. Now, third integral dx by x square plus a square. X square term plus a constant. Okay, my children. Only 2 terms will be given. Then its integration is 1 by 2a log 1 by ta tan inverse of x by a plus c. Okay, my children. This is a formula. Now come to the fourth formula, integral dx by square root of x square minus a square. Observe this function, my children. Under square root, a quadratic expression is given, and moreover, only x square term and constant term. Okay, my children. Here also coefficient of x square is 1. Keep this point in your mind, my dear children. This is important point. We have to make coefficient of x square as 1 in all the cases. Okay, my children, to apply this formula, log mod x plus root of x square minus a square plus c. Now come to the fifth formula, integral dx by square root of a square minus x square. Here also under the square root a quadratic expression, but first term is constant term and the next term is x square term. Here also coefficient of x square is 1. Okay, my children. Then its integration is sin inverse of x by a plus c. Okay, my children, understood this formula. Now come to the sixth formula, integral dx by square root of x square plus a square. It is also a quadratic expression in x under square root. Okay, my children, here also coefficient of x square is always 1. We have to make coefficient of x square as 1. Then its integration is log mod x plus root of x square plus a square plus c. Okay, my children. Now you have to learn, you have to memorize all these 6 formulae well. Okay, my children, for the exercise 7.4 sums, to find the integrals of the sums given in the exercise 7.4, you have to memorize, you have to learn all these 6 formulae. We apply these 6 formulae. Okay, my children, understood? Right. Sometimes the quadratic expression will be given in this form. See the 7th formula, my dear children. Integral dx by ax square plus bx plus c. For the last 6 formulae, if we observe the last 6 formulae, in the quadratic expressions, they have given only x square term and constant term only. They have not given x term. But whereas here x term is also given. In this quadratic expression, x square term, x term and constant term, 3 terms are given. In this case, to find the integral of this form, we have to write the given quadratic expression by taking the x square coefficient as common factor outside, and we write the remaining part as a perfect square, by using perfect square method, quadratic expression. Okay, my children, by using that procedure, we write the remaining part of the expression like this: x plus b by 2a whole square plus c by a minus b square by 4a square. Like this, we write this quadratic expression in this form and reduce the integral to the form 1 by a, because a coefficient of x square we wrote outside. Integral dx by x square plus some constant x square term, only x square plus or minus k square, depending upon the sign of c by a minus b square by 4a square. If plus is there, we can write here plus. So there is a minus, we write here x square minus some constant. Understood this point, my children? And hence can be evaluated by using an appropriate integral formula. Understood this point, my children? Right. Come to the 8th formula, same as point number 7. To find the integral of the form integral dx by square root of ax square plus bx plus c. Here also under the square root, a complete quadratic expression is given. A standard form of a quadratic expression in x is given here. In the previous 6 formulae, only x square term and constant term only given. They have not given the x term, but here x term is also given. So to find the integral of this function, we proceed as in the 7th formula. Same, we follow the same. Okay, my children, we obtain the integral using the standard formula. Then we can apply the relevant integral formula to find the integral of the function. Understood this point, my dear children? Right. Now come to the 9th type of integral. To evaluate integral of type integral px plus q by ax square plus bx plus c dx. If you observe this integrand, in the numerator a linear expression in x, and in the denominator a quadratic expression in x. In this case, if the numerator is having a linear expression in x and in the denominator the quadratic expression in x will be given. In this case, where p, q, a, b and c are constant, we are to find real numbers, capital letter A, capital letter B, such that px plus q, you have to take the numerator. The linear expression in x is equal to capital letter A into d by dx of this quadratic expression plus b. We have to write this equation. They don't give this equation. We have to find the values of capital letter A and capital letter B by writing this equation. Then this implies, understood this step, my children? This is important step. to find the integral of the type in this form. Okay, my children. This implies px plus q is equal to capital letter A into what is the derivative of this expression? 2ax plus b. Understood this part, my children? Right. Plus capital letter b. Okay, my children, we get this equation. From this equation, to determine capital letter A and capital letter B, to find the values of capital letter A and capital letter B, we equate from the both sides of the coefficients of x and the constant terms. First, we have to equate the coefficients of x on both sides. Then we get the value of capital letter A. After that, we have to equate the constant terms on both sides of the equation. Then we get the value of capital letter B. Then A and B are thus obtained. Then we get the values of A and B. Okay, my children, understood this point? And hence, the integral is reduced to one of the known forms. Then we get the integrals in the any one of the first 6 in this exercise. At the beginning of this concepts, we have written first 6, any one of that 6 forms. It will reduce it to any one of that 6 forms. Okay, my children. Similarly, come to the 10th type of integrals. For evaluation of the integral of the type integral px plus q by square root of ax square plus bx plus c dx. If you observe this integrand, in the numerator a linear expression in x, and in the denominator under the square root a quadratic expression in x. A small difference here is no square root, here square root is there for the quadratic expression in x. Then we proceed as in point number 9. Okay, my children, we follow the same steps. Then we have to find the values of capital letter A and capital letter B, and we have to transform the integral into known standard forms. Then we evaluate the integration. Understood these 10 points, my children? So by using the knowledge of these 10 points, we find the integrals of the functions in the exercise 7.4. Okay, my children, I hope you understood the concepts of this exercise 7.4. We apply this knowledge to find the integrals of the functions given in exercise 7.4. Okay, my children, right. Now come to the sums in the exercise 7.4. Okay, my children, page number 315 in the textbook. Page number 315 in the textbook. See the question number 1. First question in this exercise. Integrate 3x square by x to the power of 6 plus 1. Understood this question, my dear children? You have to integrate 3x square by x to the power of 6 plus 1. Okay, my children? Right. Come to the solution part. Let us assume that capital letter I is equal to integral 3x square by x to the power of 6 plus 1 dx. You know, first step is we are assuming capital letter I is equal to integral 3x square by x to the power of 6 plus 1. Okay, my children? Now we reduce this integrand into any one of the standard form. So to reduce this one, first we use the integration by substitution method. Here x to the power of 6 is there. Put x to the power of 6. Here we can write integral 3x square by x cube whole square plus 1 dx. Can we write it or not, my children? X to the power of 6 can be written as x cube whole square plus 1. Okay, my children, understood this point? Right. Now put x cube is equal to t. First we use the integration by substitution method and we reduce this integral in the any one of the 6 forms in this exercise 7.4. Okay, my children? So differentiating with respect to t. Then what will you get here? What is the derivative of x cube? 3x square. Here I am writing that step directly. First we have to write the derivative of this function into dx by dt is equal to Derivative of t, 1. Understood this step, my children? Right. From this equation, what is there in the numerator? 3x square dx. So from this equation we find the value of 3x square dx. So this implies 3x square dx is equal to, we transpose dt to RHS, it becomes 1 into dt only. Understood this point, step, my children? So we got x cube is equal to t and 3x square dx is equal to dt. We substitute these two values in this integral. Okay, my children? Right. Therefore, I is equal to integral 3x square dx in the numerator is there. What is the value of 3x square dx? dt by x cube. What is x cube here? We assume t square plus 1. Understood this step, my children? Right. Now it is reduced into standard form. Integral dt by t square plus 1 can be written as 1 square. Isn't it or not, my children? Right. Now it is in the form of integral dx by x square plus a square. Isn't it or not, my children? If you observe this integral, it is in the form of integral dx by x square plus, it is a quadratic expression in t. Only x square term and constant term is there. So x square plus a square, it is in the form of integral dx by x square plus a square. What is that formula? Tan inverse of x by a. Isn't it or not, my children? See here 1 by a, tan inverse of x by a. Here what is a here? 1 by. So 1 by 1 tan inverse of t by 1. We write the formula integral dx by x square plus a square. Integral dx by x square plus a square is equal to 1 by a tan inverse of, by using this integral formula we wrote this step. Understood this step, my children? Right. 1 by 1, what will you get? 1 only. So no need to write 1. Tan inverse t. Finally we got integral, but it is in terms of t, but actually the function is given in terms of x. So we have to convert, we have to transform this function in terms of x. So tan inverse of, what is t here? X cube. Tan inverse x cube. So this is the final step. Understood this step, my children? Right. Plus c. This is the integral of the given function. If you wanted to check whether this answer is correct or not, find the derivative of this function. Find the derivative of this function. Then automatically you get this function 3x square by x to the power of 6 plus 1. Okay, my children, understood this point? Right. Now come to the next question, that is question number 2 in this exercise. Integrate 1 by root of 1 plus 4x square. Understood this question, my children? We have to find the integral of this function. Okay, my children? Right. Come to the solution part. Let us assume that capital letter I is equal to integral 1 by square root of 1 plus 4x square dx. Okay, my children? Understood this first step. We assumed here capital letter I is equal to integral 1 by square root of 1 plus 4x square dx. If you observe this integrand in the denominator under square root quadratic expression in x, but what is the coefficient of x square? 4. What I said, first we have to take it out, the coefficient of x square. Okay, my children? Right. So that is equal to integral dx by if you take 4, because coefficient of x square is 4, so we have to take it out. Okay, my children? Then what will you get? 1 by 4 plus x square. Understood this step, my children? Right. So square root 4, what will you get? 1 by 2. So we write that numerical coefficient outside, 1 by root 4. What will get to 1 by 2 only. So that is why I wrote here directly. Understood this step, my children? Right. Integral dx by square root of 1 by 4 plus x square. Then we got this integral. So here constant term is there and x square term also there, and in between plus sign. But we have to write this constant as a perfect square. Remember this point, my children. Okay, my children, understood this step? Right. That is equal to 1 by 2 integral dx by square root of 1 by 4 is written as a square number, that is 1 by 2 whole square. If you simplify this number, what will you get? 1 by 4 only. That is why we are writing for our convenience 1 by 2 whole square plus x square. Understood this step, my children? Right. Now if you observe this integral, it is in the form of integral dx by square root of a square plus x square. What is the formula you have learnt? The first 6. Any one of these 6 formula. What is that? Integral dx by square root of a square plus x square. What is the formula? Log mod x plus root of x square plus a square. Do you remember that formula, my children? So 1 by 2 log mod x plus square root of a square plus x square. Okay, my children, because integral dx by square root of a square plus x square is equal to log mod x plus root of a square plus x square. By using this integral formula, we wrote this step. Understood this step, my children? Right. Now let us simplify this function. 1 by 2 log mod x plus, what we will get here? 1 by 4. 1 by 4 plus x square. 1 by 4 plus x square. Understood this step, my children? Right. Again, if you take the LCM, what will you get? Log mod x plus 1 by 2 into square root of 1 plus 4x square. If you take LCM, 4 is the LCM. If it comes out 1 by 2, we get square root of 1 plus 4x square. Understood this step, my children? Right. This implies 1 by 2 log mod. Again, if you take LCM, 2x plus square root of 1 plus 4x square whole divided by 2. By taking LCM, we get LCM is 2, then we get 2x plus square root of 1 plus 4x square. Understood this step, my children? Right. Now observe this part, my children. It is in the form of log of a by b. Log of a by b. There is a logarithm property. So we use that logarithm property. 1 by 2 into log of a by b can be written as log a minus log b. So log modulus of 2x plus root of 1 plus 4x square log a minus log b. So log mod 2, because log a by b is equal to log a minus log b. By using this logarithmic property, we wrote this step where a is equal to 2x plus root of 1 plus 4x square and b is equal to 2. So log a minus log b. Understood this step, my children? Right. Now let us multiply by 2. So what will get? 1 by 2 log mod 2x plus square root of 1 plus 4x square minus 1 by 2 log 2. Understood this step, my children? Just I used the distributive property, then we get this step. Okay, my children? Right. Now, this is the last step. So, we had to add the constant of integration. So, 1 by 2 log mod 2x plus square root of 1 plus 4x square minus 1 by 2 log 2 plus c. Understood this step, my children? Right. If you observe these last two terms, this is also constant term, this is also constant term. So if you simplify these two terms, again we get a constant term. So finally we write like this: 1 by 2 log mod 2x plus square root of 1 plus 4x square plus lambda, where lambda is equal to c minus 1 by 2 log 2. Understood this step, my children? At last, just we write only a single constant term. But here we got two constants. This is also constant term. No variable is there. Though this is also constant term. If you simplify these two constant terms, again you get a single constant term. So we denote it as lambda, where lambda is equal to c minus 1 by 2 log 2. Understood this step, my children? Right.